Good afternoon, everyone, and welcome to the Slant 3D podcast, the show about 3D printing and our place inside the industry. Today, we're going to talk about the lawyers suing the people they worked for, Stratasys raising a bunch of money, ceramic components for preventing moon dust from sticking to stuff, and finally culminating in some talk about teleport, and then who the hell am I? So that is in the show today. But before that, let's go ahead and pay the bills. This episode is brought to you by Teleport. Teleport is our new print-on-demand plug-in software that allows anyone to use our giant print farms to support their business. You can connect to Teleport any e-commerce store, whether it be Etsy, Shopify, Amazon, eBay. Wherever you're selling prints, you can connect it up to Teleport. Then whenever a customer purchases an item from your store, that order will come to us and we will print it and ship it directly to your customers for you. No more having to worry about what the greatest printer is, having to change out nozzles and having to pack boxes or know what the shipping is or what the tariffs are or which postal service is working. Leave that all to us and you can focus on designing new products and taking care of your customers. So check out Teleport today over at slantpod.com. That is the Teleport plugin by Slant 3D. Alrighty then. News. So, first piece of news. Continuous Composites is being sued by Lee and Hayes up in Coeur d'Alene for non-payment of fees. This is for their lawsuit against Markforged. So here's the situation. Continuous Composites sued Markforged a couple years ago. They ended up settling with Markforged a few months ago. Markforged paid them $25 million. Lee and Hayes is now suing Continuous Composites for not paying them what they are owed. The story is that under the terms of the agreement, payment would be calculated as 30% of any settlement or verdict. Continuous Composites has paid Lee and Hayes $3 million. Lee and Hayes is seeking $7 to $8 million because they say Continuous Composites got paid $25 million. They owe us about $8 million, one third of that, $8.5 million, somewhere around there. And Continuous Composites says that they received a letter from Lee and Hayes that said that $3 million was enough, and they acknowledged that as full and complete payment. So they are suing each other. There's nothing to be read into any of this, but it's the overall danger of getting involved in these situations. Because if you're going to sue, you will be sued. Like it's not, I'm not going to say it's karma. That's not what it is. But when you're in that world and engaging in that situation, you are playing that game and everybody else is playing it too. So here's what I believe probably is the situation. Lee and Hayes, Continuous Composites got paid a down payment by Markforged of $17 million and then had an agreement for an additional $1, $2, and $4 million over the coming years. So Continuous Composites got that, $18 million. Continuous Composites was paid $18 million. And then they say, okay, Lee and Hayes, we got paid $18 million. And Lee and Hayes says, okay, well, you owe us $3 million right now off of that $18 million. Lee and Hayes says they didn't know about the full $25 million settlement until a press release months later. So they believe that they got stiffed because Continuous Composites got more money than what they let on. Continuous Composites is saying Lee and Hayes said we paid him enough, and they said we were good, so we're good. This is the argument that's going to come out in court. But it's just one of those situations where you look at it and you're like, it is what it is. Get sued by your own lawyers. It's kind of rough. It's not clear who's right or wrong. On the lawyer's side, maybe they had an intern or a paralegal send an email along that said, oh, $3 million, that's good. Your payment is good. And he meant you're good for this month or something like that. But now it's written down record and it says, you're free and clear. The whole deal is paid off. So now Continuous Composites get to say, we paid you everything and you said we were good. So we don't owe you anymore. But at Continuous Composites didn't tell them the full funding amount that they got. So there's that too. So just be clear and upfront with everybody all the time and really elaborate on your stuff, I would say, is the lesson to be learned from this. Okay. Stratasys secures $120 million investment from Fortissimo Capital. They have announced this investment. It's an Israeli private equity firm. The deal involves a direct purchase of 11 million newly issued shares at $10.30 per share, reflecting a 10.6% premium over the company's January 2025 listing price. This increases Fortissimo's stake from 1.5 to 15.5%, securing a seat on the Stratasys board of directors and an option to add a second board member if its ownership reaches 20%. So, Stratasys is raising money. Right now, Stratasys is expected to lose about $12 to $15 million this quarter, or Q4 of last year. So they're bleeding money. They have good revenues per year or per quarter. They're doing about 120. They're somewhere in the 100 plus change $1 million per quarter. But they're not profitable right at the moment because they're spending more than they're making. So they're raising more money. Stratasys and Professional Machine Systems have taken a whacking over the last couple of years, which everybody attributes to Bamboo Lab. Because Bamboo Lab have created machines that are good enough and easy enough to use that people are foregoing a $100,000 machine in favor of a $1,000 machine. It's been hurting them. Stratasys is expecting to use inorganic growth methods in order to use the money in order to pursue inorganic growth methods, which means they're going to be acquiring companies. They're going to use this money to try to acquire other cash flowing companies in order to grow themselves. It's interesting, raising money at that valuation. They're at a fairly low valuation right now. It's not a big premium. Fortissimo is getting a deal in the moment. It's certainly a long-term play on the expectation that Stratasys will be able to continue to grow, but there's no guarantee that they will. And Stratasys is in a tough spot because they are a really high expense machine company who is competing against a very low expense machine company. It's a different world and it's a different context from what they're used to if they are indeed intending to compete with Bamboo. I don't know why they would. I don't know why very many companies would try to pursue consumer 3D printing right now as a follow-on, because it's owned by the Chinese manufacturers. Where Stratasys can differentiate themselves is through continuing to have very application-specific sort of machines, where they're like, here's a $100,000 machine, but it's the only one that can print this material for these shoes or something like that. That's how they can maintain competitive, just these really niche, high-value turnaround options, or like dental aligners and that kind of thing, these really optimized systems. Those are the types of things that Stratasys could do. And they have $120 million now to do all of that, which means that if they're losing $12 million a quarter, they have 10 quarters, 2.5 years to figure out a solution. So that's an option. It's a solution. It's a thing that's going on. Okay, next, article number 3. Embry-Riddle Aeronautical University installs first Lithos CeraFab multi-3D printing system in the USA. This article is in here for 2 reasons. Generally, we don't talk about these installs, but number 1, Embry-Riddle is my alma mater, which will be relevant later on. And number 2, the application of this is really interesting because the machine's multi-material capacity, as well as its ability to facilitate complex geometrical features, has already helped Embry-Riddle to produce bio-inspired patterns for NASA challenges. These patterns were said to mitigate dust adhesion on lunar surfaces and were modeled after hydrophobic surfaces like the lotus leaf. What all that means: moon dust is stupidly sticky and wildly abrasive. It is shards of stickers that are the size of grains of sand, and they stick to everything because the dust of the moon is electrostatically charged, so it just flies up and sticks to you from static electricity. These are all very bad things. But what the researchers are doing here down at Riddle is they are creating a micro surface that is able to mitigate that to where I don't know what it is. I honestly do not know what the pattern is on a lotus leaf that does this. Whenever I think of this, I think of like shark scales. Shark scales are really hydrodynamic. Those types of microstructures can be applied to something to keep dust off, that kind of stuff. So, and 3D printing can create those structures where nothing else can. That's the interesting application of this, because with everybody going back to the moon, the dust is a really flippin' hard problem that was never solved. The dust tore up the rovers, it tore up the spacesuits, it tears up your lungs. It's stupid, terrible stuff. It's like asbestos. It's that bad, maybe even worse. I don't know. But to be able to use 3D printing to create materials that would be able to prevent the dust from sticking to them is a really cool opportunity and a really neat piece of research. So yeah, that's just a nifty thing. Alrighty then, company updates. Teleport. Teleport, right now, average shipping time for orders is about 2 to 3 days. We're hovering right around there. Some orders with a large number of parts are getting up to 5 days. Some brand new prototype orders sometimes take longer. We have put in optimization inside of the system to where this is how we do it, guys. So prototype orders are not like time critical. So we will deprecate those in favor of actual customer orders inside of Teleport. So prototypes can sometimes take longer. We're working to change that though, because from a customer experience, it's not really clear or obvious that prototype orders would be replaced. So we're flipping that again, because the prototype, if somebody orders a prototype inside of Teleport, that's generally the very first interaction with Teleport. So even though it's really not mission critical, it is the mission critical for that customer. I mean, their customer is not going to be ticked off if that order arrives late because it's coming to them. It's a prototype. But they are ticked off at us because that sets the expectation of how long stuff needs to come. So even though it is better to make sure that everybody's real customers are happy, we need to make sure that our customers are really happy. So we're dealing with it, and mainly the solution to that is just parlaying more machines over to Teleport. Right now, the factories are still kind of split between normal production work, and Teleport orders and that kind of thing. And Teleport is growing really fast, so it's starting to absorb capacity. So we're expanding and we're moving and we're reallocating machinery towards Teleport as quickly as possible so that stuff is shipping faster. But there's a limit to how much we can do that, because we can't load up 50 machines with purple when one person buys 50 parts of purple and then doesn't come back for 3 months or something like that, as a random example. So the deployment of Teleport is a lot more organic, to where it can't instantly flip on new capacity to where we're running in these time delays. But we're going through and optimizing it. One of the primary focuses this year is to get the average ship time for any Teleport order down to under 2 days, and total delivery time from us to a customer to under 4 days. Those are our operational targets for this year. Right now we're above that. So, but we need to get it down below 4 days, because that's just kind of sweet enough to where it's useful to everybody. And then as we deploy more print farms around the country, around the planet, we'll be able to get that down below 2 days, because we should be close enough to have 1 to 2 day shipping, and no part should physically take longer than 24 hours to print, so long as there's a machine to take it as soon as it shows up. So those are the things that we're fighting through on this. Third-party components are in there. We released third-party components at the beginning of January. We are releasing a bunch of content and documentation and all of that stuff here over the next couple of weeks. January was a big old cleanup, kind of retrenching period for us guys coming out of Christmas and just breathing for a moment. So we're revamping that and deepening that offering here. So they'll expect a lot more content explaining third-party components and that kind of stuff coming through soon, so that there's really good help and resources for that, like negatives to cut them out of parts, obviously dimensions, and all the rest of it. And you can order the third-party parts inside of there. We're also going to add a few more, but we're going through and just revamping some system stuff right now before we expand products. New customer support, that is coming through. So last show or a couple shows back, I talked about the customer support problem on Teleport of like just all the different areas. We are getting this boiled down to one, and we are likely going to build out a Reddit page. Well, maybe potentially a Reddit page. This other one is kind of in on it also, of just like a home base of content. But we are expecting a Reddit page and then a single form contact which will have both AI assistant inside of it, which is trained by us, and then our own team managing and monitoring messages. Though this is really interesting too. While we were going through and looking at that system, designing that system, guys, we're really AI forward. We use AI in all of our stuff, and AI is a huge enabler for all kinds of things that we're doing around here, both what we've discussed and behind the scenes. Like, I don't believe that AI is overhyped. I think it's still underhyped. The value that it creates and is around is bananas. Literally just this last week or so, we got a seat in ChatGPT Operator. We're testing out Claude's desktop control, whatever they call their thing. And those things are fantastic. Like, just amazing what they're capable of doing. And then, yes, DeepSeek is around and it's stupid cheap and can run on your local computer and that kind of stuff. Like, but the utility of these things is bananas. All of that is to say, while we were running through and working with this problem, we got something boiled down to where we're like, oh my gosh, huge sections of the UI of like Teleport might be able to be eliminated and simply replaced with a chat box, where you will type in, hey, I want to refund this order or something. And you'll talk it through and say, yeah, I want the refund. This is why. And it'll say, okay, cool. Refund's been processed. Done. You don't have to go search for the button or anything else. You just say you want to do this. And it's really great on the application dev side because we don't have to build this whole front end. You build an API and then you build the chatbot on top of it and train the chatbot on top of it. And then the chatbot integrates with the API and is the interface to you, which is way more natural than wandering through menus and stuff. It's really bananas how this is going to change like front end design. I'm excited about it because these mundane tasks inside of it, like, oh, upgrade your subscription or something, are always kind of tedious, or downgrade your subscription, whatever it is. They're always kind of tedious, and they're also never given love by the development team because they're not cool features. But now the UIs of applications will be able to be so wonderfully distilled to where this button does this, this button does this. If you need to do anything complex, talk over here and ask what you want to do and it'll happen. It's very Jarvis-y, where you're just like, I need to upgrade my subscription. Okay, what do you want? These are the 3 available. Oh, I want the 15 right there. Okay, yeah, you can do 15. Are there any discounts available? Yeah, sure, I can give you a discount. Here, go. If you grab it for the next 3 months, though. Okay, cool, done. And it's done. You don't have to search through and read. You just have the conversation. And the rest of the app is big blue buttons where buttons are faster than speech or more expedient than speech or scrolling through stuff and that kind of stuff. So as a product designer, it's really exciting to see how digital products will evolve with this new kind of AI enabling layer. That's a side tangent, but there, in addition to that, with Teleport and with all of our systems, we're doing kind of a revamp of the entire stack right now. Again, last year, we built a bunch of stuff, and now we're going through and pruning and cropping and twisting the stuff of like, this is what works, this is what people want, this is what people don't want. Okay, this is core truth right now. Get that baseline done, that's foundation, go. So there'll be a couple months here where you won't really see the new features for the most part. But then stuff will start ramping up very quickly. Oh, by the way, another UI component in the context of customer service and the rest of it, and QC expectations for us. Like if we ship a bad part, what do you do inside a Teleport? Well, you send us a request and we generally refund anything that shows up broken or wrong or that you don't like. But you have to send that request. I'm considering, because I can make this decision, just literally putting a refund button, like a single click refund button next to every order. I'm considering it. It's not definite yet. I'd love to hear what people have to say in the comments, but it'd be really new and different because everybody has single click buy, right? But there is not single click refund to where it's like, I didn't like this, refund, done. And you get your money back. No questions asked. Well, we probably require some questions. You're like, you have to fill out this text with something so that we know why you didn't like the part and so that we can improve. But just super low friction refund. Oh, we're not doing returns. Returns are useless to us. We make everything on demand. You can't do returns. It's good because we don't have wasted inventory. But just an automatic refund because print quality was not where it was or something along those lines. Or an automatic like reprint or reship, something along those lines. It's just super low lift. I like that because it's a really slick customer experience and just wildly bananas that nobody else would ever do. But it's really great for the customer because, first of all, it makes it stupidly clear what you do if we screw up. If you don't like our stuff, hit that button and we give you your money back. No questions asked, no fight, no hoorah, nothing. That's really good, especially when 3D printing is gaining trust right now. I just like it from a UI standpoint because I hate processing refunds. So why would I want to build something that I hate in other people's stuff? And it's also so different from what everybody else does. And I just kind of enjoy that once in a while, just to kind of stick it to how everybody else is doing it once in a while. The danger is abuse. But abuse is identifiable. Like, oh, this user orders every item and then refunds every item, or refunds 95% of their items, or whatever it happens to be. Okay, deactivate their account. I mean, that's pretty easy to catch, that sort of fraud or abuse. If somebody is refunding 25% of their orders and then they keep on still taking new orders without shutting us off or something like that, they're just trying to screw us. So don't use them. I mean, it's identifiable. We'll take a hit, but it's a really clear way of sorting good quality users. And it makes everybody feel safe in the situation. And yeah, we're a moderator of our account. We don't have to serve anybody we don't want to. So we can shut people off anytime we want to if they're abusing the system. So yeah, really heavily considering that. I want to add something like that. We need to refine it a little bit more. There's some user experience there that we got to do so that, again, we're getting some utility from it. Because if people hit refund often, we want to know why. Did it show up late? Was it a bad print? Whatever it was. So we know where to improve and fix it. Because it's a very clear feedback thing. Oh, we're having lots of people process refunds because we don't ship stuff right. We need to fix something right now. It's a very clear thing that's better than stars or thumbs up, thumbs down, or hey, leave a survey if you liked us or whatever else it was, because it's deeply honest. So that was a lot more about Teleport than I thought we were going to do. But Teleport, by the way, still growing fast. We're staying ahead of it. We thought we might have to shut off signups for a minute. I don't think we're going to have to do that. We're getting out ahead of it to where it's a thing. But anyhow. Okay. Who is Gabe Bentz? So this, okay, hang on. Let me make a note here real quick. So, as many of you guys know, we've mentioned in the post before, we've been doing a Series A. And what comes up from this very often is, Gabe, what the hell are your qualifications to be running a company like this and doing this kind of stuff? And I had this conversation a lot because, quite frankly, I don't talk about myself very often, and this is weird and awkward. But we thought it would be a good idea if I just sort of gave my life story here so that there's a record that other people can go reference to find out my history and qualifications for what we're doing whenever somebody's like, why the heck does Gabe Bentz run a 3D printing company? So many of you know, I hope or presume, I'm the CEO of Slant 3D. I am the original founder of Slant 3D. And Slant 3D was spun out of a previous company that I ran in 2019. And now I run this thing. So how did I get here? Well, let's go back to the beginning. I was born in the early 90s into a ranching family. I am one of 5 siblings. I'm number 4. A ranching family, terribly rural part of the world. And by terribly rural, my nearest single neighbor, who I wasn't related to, my nearest neighbor was 1 mile away. We lived under this hill, and they lived under this hill. I am able to yell because you're dealing with those distances. But I was born number 4 to this ranching family, working ranch, very rural town. My parents are cattle ranchers, pure cattle ranchers. We don't grow corn or soybeans or anything like that. We grow beef. The hamburger, the steak, whatever it was, that kind of stuff. Whole, healthy, real food. We would move cattle up the side of a rocky mountain, and the cows would eat bunch grass on the side of that rocky mountain that would otherwise be useless, and they turn it into beef, which can be useful. That's where I came from. That's how my parents made a living and how they fed us 5 kids. Growing up on a working cattle ranch, you start working when you can walk. Literally, one of my earliest memories was probably like 4 or 5. In the winter, you feed the cattle. There's no grass around, so you mow down and you farm hay during the summer, which is grass rolled into bales. And then you feed that hay to the cows during the winter while they're having calves and everything else to keep them growing. One of my earliest memories is there was an old army truck that was literally from like the 1950s or 60s. And my dad would put it in gear and he'd put me in the driver's seat and he'd say, drive that direction, don't drive into a ditch. And me as a 5-year-old was to be eyeballs and 2 hands on a steering wheel, literally like this big around, and steer this truck while my dad and other folks or brothers and sisters were on the back throwing off hay for the cattle. So that's what we did. When you start out at 5, you start working. You get up at the crack of dawn. You are out of the house by 7 a.m. and you're starting doing something. In the summers, in the springs, you're calving cows, which is they're having babies, and you're taking care of them. And then in the summer, you're moving cows up the side of the mountain to where the grass is, up in the side of the hills. And then while they're up on the side of the hills, you're haying the meadows and that kind of stuff to store up hay for the winter. In the fall, you're vaccinating and doing all this kind of stuff to make sure that they're staying healthy and taking care of the cows. And then in the winter, you're feeding the cows. And then you rinse and repeat my entire life. And my parents have been doing it for 50 years. I am deeply appreciative and thankful for the family and for the lifestyle that my parents introduced me to. Because being a ranch kid makes you fantastically independent and resourceful. There are no resources. You have you and your brother to survive. That is what it's like. The nearest Walmart was 120 miles away from me. The nearest grocery store was 60 miles away from me. The nearest gas station, formal gas station, like an Exxon or Chevron or something like that, 60 miles away. We stored tanks of gas on the ranch there to run all this stuff. We would, when you when you chase cattle up the side of the mountain, you are 10 miles and a 2-hour ride away from home house. You're out in the wilderness on top of a forest or something along those lines. If you get bucked off a horse, and by the way, a horse has a mind of its own and will do that to you. Horses are an incredibly dangerous means of transportation. But if you get hurt or something like that on the side of the mountain, you're on your own. You drag yourself off the mountain. And this was a very real reality to us very early on, because I had siblings who were bucked off of horses. When I was a kid, my dad got bucked off, got a concussion, that kind of thing. We had to take him to the hospital. Fortunately, he was only like 20 minutes away from the house, so we were able to get him drugged back and taken care of. But ultimately, there's no help. So you act carefully, but decisively, and if something goes wrong, you deal with it, and you don't wait for somebody else to come take care of you. You just become wildly independent. Also, since we were up at the crack of dawn at 7 and working as soon as we could walk, work ethic was just fantastic. Like, we're a religious family, so we would take Sundays off. Sundays were a rest day, generally, but there was still stuff to be done, so all of us would putter around and do something even then. But the typical day would go from 7 a.m. to 5:30 p.m. That was the clock hours. I don't remember ever following that time short of like haying season when like you're just done and you can see a clock. We didn't have wristwatches or anything like that. You when the job was done is when you got home. But like moving cows on the side of the mountain, you move the cows until they were up the side of the mountain. If you hit 5:30 or whatever else it was, and you're still 2 miles away from where the herd is supposed to be, you're going to finish where the herd is supposed to go. There was none of these kind of typical systems where it's like, oh, well, you're on for 8 hours and then you're off, and then a 15-minute coffee break and a 1 hour this and something like that. It's like, no, you show up, you work until the job is done, and then you do it again the next day. And the reason you do it is because that's what puts food on the table. That's the thing. So that was the lifestyle growing up. Growing up, though, a ranch is an operating business. So around the dinner table and that kind of thing, I was able to hear about hay prices and beef prices. And my family, my extended family, is kind of has a history of being German merchants. So we just are... we just always are kind of thinking about business in that sort of way. And we have slightly better humor than most of that ilk. But anyhow, so the business was always kind of a part of life. Really hard work was always a part of the life. And just kind of long-term thinking, like if you run a cattle ranch, the only way to do it is for 20 years. You don't pop in for a year or 2 years and then pop off to the next job and get an upgrade. In order to be successful in cattle ranching, you have to do it for 10 to 20 to 50 years. And if you do that, then it can work. If you don't do that, it will definitely not. And this is what many farmers and agricultural folks understand. But that long-term thinking was just kind of instilled right from the start of like, oh no, we're committed to this place for life. You're not going to switch over to this job or switch over to this job. It's just very consistent, which was also a really good value to learn because in general in life, job hopping and that kind of stuff does not have as high of a value as many people realize as opposed to becoming really good at something. So really appreciative of that. Growing up, got to do things like 4-H and that kind of stuff where you grow a beef steer and then sell them off at the end of the season. Working on the ranch during the summers, I was able to work for salary and help out other neighbors and that kind of thing. So I was a working employee from as soon as I was legally able to be. But on a family ranch, you start working really early. And when you become useful, then you can maybe pull down a salary. Because a 5-year-old is not useful. You can keep an eye on the road and maybe not drive into the ditch, but that's not always the case. So anyhow, grew up in that, went to a one-room schoolhouse. My school was K through 8th, 13 kids. It was 8 miles away from my home, which is not that impressive. A lot of people are that far away. Dirt roads until I was about 10, and then the roads got paved. So just, again, I'm painting how rural this was. I run a technology company right now. Gabe, where was your exposure to the Apple II back when you were young or whatever it was, like all these origin stories are? Never had that. I knew I was interested in robotics when I was 4. I knew I was going to be an engineer when I was about 4. I watched a movie, the old Lost in Space, black and white. It was Robbie the Robot versus the B-9 in Lost in Space. And I was like, that's what I'm going to do. I'm going to build those robots. So really early on, I found out what my calling was and stupidly blessed to do that. And I worked on it since I was 5. I have been in robotics and that kind of thing, mainly on mechanical design. Because on a ranch, I get to weld together metal and that kind of stuff. There was a shop with tools. I was able to build things. Was not really exposed to typical modern technology, digital technology. I learned programming and that kind of stuff probably when I was about like 15 and stuff. Or, well, no. It was earlier than that. When I was about 12, it was like Arduino, early C, that kind of stuff. I had a book for game developing that I found. The very first book that I bought about robotics was Robots, Androids, and Animatrons. I bought it from a Radio Shack that was in the back of our feed store. That's what it was. The book cost, I think the book cost like $15. I saved up for like 3 weeks to be able to buy that book. Maybe more, maybe a couple months or so. But yeah, it was a big deal to buy that book. And I continued to be hooked. But was in robotics the entire time. Family was very supportive. I really appreciate my family. Even though I wasn't really going the ranching direction, they were like, Gabe wants to invent stuff and build robots. Go for it. So the going from there, one-room schoolhouse, went to school in the town 50 miles away. I would live in town during the week. I'd come home, help out on the ranch on the weekends. Because that's what you do. You're not going to drive into town 50 miles every day. We couldn't afford that amount of gas or anything silly like that. And it was also a waste of time. So we would live with family, friends, or my grandmother in town, go to high school, did pretty well in high school, graduated, did all the things, that kind of stuff. I did football, basketball, track, and golf because the school total had 350 kids when I was in it. My graduating senior class was 50 kids. Valedictorian. But again, the small schools have all the problems of small schools, but also have the advantages of allowing you to be in sports. And sports was like the very first like really engagement with like teams that I ever had, because everybody always goes to high school and you find out what a cruddy team is. A cruddy team is your teacher assigns you, this guy, and another person together, and one person ends up doing all the other work, and the other people end up standing up there in front of the PowerPoint. Sports allow you to understand what good teams are. A bad team is where 2 + 2 = 3. The average team is 2 + 2 = 4, which is just a group of people in a room, and they all do their job. A really good team makes 2 + 2 = 5. That is when everybody's just hitting on all cylinders and you're bouncing off of each other and there's just energy and electricity in how you're playing. And you're like, we're down 2, but we're going to get it done. And just everybody's just like in the same zone and focused, and magical stuff happens. You get to see that in sports. Really magical teams. And being a part of that is really, really incredible. And equally, you get to see on teams the different dynamics and personalities on teams. That guy's a dick. That guy's the jock. That guy's insecure but pretty good at this. So you feed him the ball when he's in a good spot. That kind of stuff. So went through high school. I'd say through high school, I was a very prototypical nerd/performer. Very by the book. I did what I was expected to do because I was trying to get in MIT. I did not get into MIT. I was actively rejected by them. And looking back on it now, they were correct about that because I was the prototypical nerd. I remember I was talking to a friend of mine who was an MIT graduate. He's a friend of mine now. He wasn't back then. He was an adult and I was a child. But he was like, to get accepted in MIT, you have to show why you're different. Because every other single person there has a valedictorian who's captain of the football team, who's got all straight A's and is applying to MIT because that's what you do. How are you going to use the education to do something exceptional? That is the question you have to answer when applying to those types of schools. Why are you different and special? Admittedly, this is back in like 2010, 2011 when I was doing this. The world may have changed since then. But that was really important. I did not understand that then. I understand it much more now because now I hire people and that kind of thing. And that's the thing you look for. I don't care what your resume says. There's 50 bajillion people out there with a resume stocked full of good grades and past experiences and leadership experience or whatever else it was. But people with like vision and intention and really clear goals are really quite rare. And it's incredibly differentiating when you see someone on a mission. And it's really incredible when you see someone who's a high school student on a mission. And that's somebody who is a lit match and you just want to dump gasoline on him, as opposed to somebody who's going through the motions. And in that point in my life, I was going through the motions. I was just get good grades and you end up going to a good school and you do what you do, blah, blah, blah. Anyway, I ended up not getting accepted to MIT, wanted to go to Texas A&M, would not give me my major. So I said, screw you. And I ended up going to Embry-Riddle Aeronautical University, which was the #1 school for undergraduate aerospace engineering. And I was studying aerospace engineering. Ended up going to Riddle. They gave me a scholarship and everything else, which was really important because my parents weren't involved in the funding of my education at all. When we graduate from high school, we're out living our life. Do what you want to do. They set us up with the tools for success of how to get a job and be a functional human. But now, if you want to go to school, that's your decision as part of your life. It's not a continuation of my parents' responsibility. So that's my parents' philosophy on that. So I paid my own way through school. During school, obviously had the scholarship. Freshman year and stuff, I worked as a reporter. I worked in the cafeteria, those kind of things. Subsequent years, I was an RA, and then I had side hustles and stuff on the side. I was doing businesses on the side the whole time. Freshman year, I was working on grants and doing a little bit of research work. At this time, for my high school senior project, I had built a passive exoskeleton, which used springs instead of counterweights, so that you would be able to lift heavy backpacks and not feel the weight of the backpack. That was the theory of that. Where my theory was, you put the guy in really sick armor that's full bulletproof, and he can stalk through like a freaking Iron Man or a Warhammer Marine, and a normal guy could move this big heavy armor. So I was continuing on with the exoskeleton stuff, which also extended into prosthetics in my early years at school. First couple of years of school, hated it completely. Like I said, I was very by the book throughout high school, and that obviously failed me because I did not get to the goal that I wanted. I was in the school that I didn't really necessarily want to be at originally, even though Riddle's a really, really good school. But hated the first 2 years because it was kind of these typical, you have to take these classes, these are your prereqs, that kind of stuff. And I'm like, none of this is engineering. None of this is getting me closer to building rockets or robots. So I ended up leaving Riddle after 2 years. I dropped out. And I left for... I did not expect to go back. I didn't think I was going to go back, but I left school, and that next year I worked and I did everything. I wrote a couple of books. I wrote a movie screenplay because Amazon Prime Video was just getting started and they had an open request for screenplays, so I did that. I worked odd jobs, that kind of stuff. I experimented with Kickstarter. I learned the current state of web development and that kind of stuff through like online classes and those kind of things, and built a couple of apps and websites. Ended up doing door-to-door sales, and I was a really good salesman. I started selling like internet door-to-door, and I was one of those terrible people that you all know. But I was good at it, and I was like top 50 in the country for a while, which was weird to me because I was an engineer. I'd always been an engineer. I was a nerdy kid. But I also apparently could be good at sales if I wanted to. I didn't really enjoy it, but I could be good at it. But it was really useful later on in my life and starting up new businesses to know like the sales process and like the most fundamental form, and to be able to practice, and also to take the pain of that, because be kind to the door-to-door sales guys, because like it is rough. It's cold outside, and you're playing a numbers game where you have to knock on 100 doors to try to get to the sale that you're going to get that day. And everybody hates you, and nobody wants you to be there, and all the rest of it. And it's totally understandable. But anyhow, worked through that whole year continuously, doing all kinds of stuff. Nothing really hit. None of the projects were working. I made a freaking custom pancake mix company. I can't remember if I put it on Kickstarter or not. Maybe I did. I can't even remember the name of it now, but did a bunch of stuff. None of it stuck, so I decided, okay, I'm settled. I've done all the things that hoorah I think I could do, or something like that. I'm not a famous author, and I'm not a billionaire after 6 months, so I guess I'll go back to school. There's also kind of just a shift in mentality. When you're young, nothing happens fast enough. And over that year, I kind of broke that bone in my body to where I was like, it will take time. And just a calm and zen sort of hit me, where it's like, I'm going to roll with the flow of destiny, and God will put me where he wants me to be. And I have to take the opportunities as they come, but I'm not going to be able to force much because I'm supposed to be wandering off. So I went back to school, continued to be an RA, went on through. Graduated. My senior research project was a spherical robot, a spherical military robot that was meant for observation and surveillance. That got me a job offer when I got out from one of the few companies doing spherical robots at the time. It was really interesting. It ended up turning into a research paper, which I did not put my name on. I was like, I don't care about the paper. Whatever. I'm not going to be an academic. I'm going to work. You guys put your own authors on it or something like that. But we had redone the kinematics for a pendulum-based spherical robot and compensated for the singularity problem on them. So we re-derived the kinematics of that in a way that nobody had ever done before, because spherical robots aren't really a very well-defined area of robotics. That senior project was probably the first times that the kinematics of a spherical robot had been fully defined and derived. While I would say that was a team effort, I was good at the kinematics and that kind of stuff. I was quite good at them, but it was a full team with that, and there were several other brilliant people on that team. But the contribution that I would say was my own on that robot is, if you have a spherical-based pendulum robot, you have the main axis right here, you have a ball around here, and then you have a pendulum right here swinging side to side. And the ball rolls this way, and it rolls this way, or you tip the pendulum this way, and the ball rolls that way. The issue with that is that the pendulum intersects with this axis. So you can't just roll sideways, because this pendulum can't roll through. What I did was I redesigned the mechanism inside so that it could. And the mechanism was not like, oh, I found really small motors or whatever else it was. No, the full axis was still full of stuff. But what I did was very simple solution, and it's a stupid obvious solution when you say it out loud, but not really recognized. What I did, instead of having this axis bend straight forward right here at a 90-degree angle to it, I twisted it by 20 degrees so that it would bend this direction, which messes up the control system of the robot, which is why we had to rederive the kinematics for it all. But I considered it a really brilliant solution to eliminate the problem of the singularity in the robot. A singularity is when all the motors align and they have to spin at infinite speed in order to get the robot out of a position. So a singularity on a pendulum robot is like if the pendulum aligned with the side axis of rotation right here, this axis could spin 1,000,000 miles an hour, but the robot wouldn't move anywhere. So a singularity is effectively a point where the motors can do as much as they possibly want, but the robot will not change position. These are things that are bad. And you try to design your control systems and your mechanisms to not allow those to happen. But I eliminated that, both through the mechanical design, and then we redid the mechanism. The other project that I worked on, since I was coming back from another year and was graduating in 3.5 years, I had to do one senior project with one team and another senior project with the other team. So I worked with the mechanical and controls team on the spherical robot. And then the previous semester, I worked with the team doing a campus tour robot. And in that project, I designed the vision system, which was using the Python libraries, OpenCV, there we go, OpenCV and those type of libraries in order to create a vision system. And what I basically did was I took a webcam feed from the front of the robot, ran it through a number of different transforms and visual filters like Huff transform and that kind of stuff, if anybody's fans of visual computer vision, in order to delineate the edge of the sidewalk and the overall location of the robot in space to qualify alongside of the GPS on the robot. So I got to design a vision system based off of a single webcam, which, by the way, single webcam vision system's kind of hard to do. You have to pull visual markers from the scene in order to get a reference for it. And again, this was a little while back ago. Right now, you can freaking plug in a ChatGPT API and it would tell you where the robot is and how far away it is from the sidewalk. So all you kids get it easy now because we've solved all these problems. But at the time, computer vision was a really hard problem. I would say that computer vision is pretty much solved right at the moment, and people don't really realize it. But did all that. So I thought I had pretty significant contributions on that. I was also the founder of what was called the Innovation Lab at Riddle, which was a student build space and that kind of thing, because we didn't have access to the machine shop. And not having access to the machine shop was one of the reasons I left school the first time around, because I'm like, I'm a freaking freshman and I'm not allowed in the machine shop. This is what I came here to do. And I had one professor tell us literally in class, you're an engineer, you don't build the stuff. You design the stuff. And I was like, well, fuck this. I'm not doing that. But anyhow, so I got the dean of students and everybody else up in a roar because I kind of knew everybody. I took a parade of students down there and said, like, hey, we want to do this. There's an empty building over there. We're taking it. And it ended up happening. I don't know if it's still there because they've remodeled the campus a lot. They might have knocked down all those places where those were. I was at the Prescott campus of Riddle, so northern Prescott, Riddle, Arizona. My college education, a lot of people ask me if it was worth it or not. Number one, I was an engineer, and I think engineering is a very valid college degree to where there's things to be learned there, if nothing else than about the thought process. For me, though, coming from a ranching background, I already knew how to make good decisions with limited resources, within constraints. So that wasn't my first experience. I had designed a remote control system for a TV 145 tractor when I was in high school so that my dad could steer the tractor from the wagon rather than having a 5-year-old up there looking at it all. So I knew how to do stuff with limited resources, which is what an engineer is supposed to know how to do. What I found interesting at Riddle was really the observation of how people pursued problems and the different abilities and how people set up that problem set and thought about them, because I was able to see different engineering styles and also different personas that you do and do not want to be. One of the things that broke me out of like normal nerd know-it-all kind of style, which is what I was for a long time, typical high school nerd know-it-all. Oh, the clouds move in different directions because the air flows in different air currents, that kind of stuff. To stop being the irritating person, I got to observe it in other people. And that was the very first time I got to do that, because a lot of people at Riddle are just really astounding intellects. I would say one of the smartest guys I ever knew was one of my roommates, and he was a concert-level violinist, and he's an F-35 pilot now, but just a freaking brilliant person and a fantastic human being. But the ease of which he did stuff, he was truly, truly brilliant. And I've only met a couple truly, truly brilliant people in my life, and he's one of them. But anyhow, being able to observe those different styles was really useful for me in my career to see now understand how to manage projects and manage people and that kind of thing, which is a lot more of what my job is now. But then also how to appropriately communicate and define certain problems, because people get in the weeds way too often. There was a project, you can have your cake and eat it too. There was a project junior year, senior year, something like that. Machine design class. We had to build a winch as the final project. And the professor used this as a chance to teach us all a lesson around engineering. You can have it fast, good, or cheap. That's what you can have. And he was going to educate us about this with this winch project. He'd been doing this for 20 years. And what your team does was you were given a budget and you could build the most accurate winch that would follow the math of what you predicted it would do. You could build the cheapest winch, which is you just build a bunch of crap and slap it together and like, cool, it kind of works. Or you could build the strongest winch, which means that it wouldn't be the fast. Oh yeah, you could build it fastest, most accurate, or strongest. Because if you make it fast, well, you give up strength because gearing. And if you make it reliable, well, then you just increased costs, so you're going to have to compromise the other two. I was in my team, and I just said, hey guys, we're going to win all 3 categories. And they were like, Gabe, that's impossible. You can't win all 3 categories. It's the pyramid of success. You can't do this. And I was like, no, guys, we'll just make our own gears and they'll be fine. And if you make the gears really big, then they're automatically very accurate. And I can carve them out of wood down there at the shop. And they're like, you can't carve gears out of wood. And I was just like, I was amazed by this. And I was like, I can absolutely carve gears out of wood. Side note, going back a little while, high school favorite class ever, woodshop. Woodshop should be brought back to high schools. It's the most valuable engineering education that anybody could possibly have. It is more important than calculus or math class. Woodshop. How to make something uncontrollable do what you want it to do. Make nature, wood, be square. Wood is not square and doesn't want to be square. The amount of problem solving inside of woodworking is astounding. But anyhow, I had done woodworking for a long time. I was like, I can take a 3/4 inch board and carve gears out of it in like 2 seconds. And they were like, it's not going to be strong enough. So that afternoon, I went down to the machine shop and I said, what's up, Joe, who was the machinist? He was like, what's up, Gabe? And I said, I need to carve a piece of wood. He's like, go crazy. I went and I carved out this gear that I printed out. I just downloaded an image from Google, put that profile, glued it onto a board, and then carved it out with a bandsaw. And I said, guys, here's a gear. And then I beat it against a brick wall until it snapped. I was like, does that seem strong enough for you? Yeah, that's what I thought. So we carved up some gears and we built the winch and we sweeped everybody. We were the last ones to go. And this thing made the most gorgeous clacking noise ever. But I was terribly happy about the situation because we won all three. We were the cheapest, we were the fastest, and we never hit the bottom of strength. We used up all the weights that were available for the test, which was just delightful. Someone else may have been more accurate because they used worm gear, but they were going for like half an hour and we were never able to time it. And I had some sloppy gears. So maybe there were like 4 categories or something. But anyhow, we won it all. And I'm taking a lot of the credit for this. But what was hilarious, and this was the most fascinating thing to me, is the professor was deeply put out about this. So the next semester, he comes around and he announces this project to the next class. And he says, we're adding a new rule this year because your teaching assistant, me sitting in the back row, won everything last fall by making wooden gears. So I'm adding the rule that you can't make your own gears anymore. And I was like, whatever, cool. He'd done it for 20 years. No one had ever done that before. And what was really fascinating is that it was stupidly obvious. This is stupidly obvious. As I say this, everybody's like, carve wooden gears? Of course. Why wouldn't you do that? But it had gone 20 years without it occurring. And then after he said it to everybody, multiple people who were in the class who knew me came back and said, Gabe, doggone it, you took wooden gears. We were going to do that. And all I can do is smile and nod because he'd gone 20 years and no one else ever had. So that was a formal experience, a forming experience for me, because I realized like maybe many people had thought of it before, but nobody had ever acted on it. And the difference between having the idea and taking the action is infinity, because it's 0 and 1. Infinity in between. Maybe other people had the idea, no one else had ever pushed on it before, which is really indicative to starting the company. Seeds of this. Starting the company. Graduated from school. I had one job offer when I graduated to work at a prosthetics company because I was really interested in prosthetics still, to utilize my robotics background. And one of my professors ran a prosthetics company. So he offered me a job. And he pulled that job back 3 weeks later. Another forming experience. Flippin' screwed the college kid. Like that's deeply lowbrow and wildly reduced my respect for him because he offered me the job. I accepted it. And then 3 weeks later, he pulled it back because the other guy wasn't actually quitting or something. And generally, I consider that, well, that's a you problem because I just put down first and last month's rent on a place or something like that. I started moving my life in a direction. But nope, job disappeared. At that point, I decided, there's no place else that I wanted to work. Everybody coming out of Riddle very often goes to Boeing. There was no way in hell I was going to work at Boeing. I was not going there. And then the places that I would go, at that point, I kind of wanted to go to Tesla or SpaceX, but I thought SpaceX was kind of done. The Falcon 9 was finished and landing. So I was just like, they've solved it all. It's all done. They're going to go land on Mars, but I don't want to build Mars habitats, and I don't want to work on a 10-year project to build stuff. If I'd known about the Starship program, I might have changed my mind. But anyhow, during school, I had started up doing product design consultancy and had started working with a couple of friends on this. So when I graduated and they were loose and that kind of stuff, I kept on doing it. And I moved up to Boise, Idaho to do that because I could do it remote. And I decided to move to Boise because Boise was growing at 3 to 5% a year organically. And I was like, hey, if I hold my shingle out here, there is wind in my sails because the economy will just grow with you. Your business will automatically grow at 5% a year, which is exceptional. You don't want to move to a dying town. So, and I also thought Boise was up and coming and had technology coming. Turned out to be wrong about that. One of the largest mistakes I've made in my life. But moved to Boise, worked remote. Recent grad college kid, I leased an office and I started working and paid the bills each month. That was the goal. Worked with a couple other guys. The company then was Slant Concepts. And Slant Concepts had a very particular intent when I started. During my senior year, I was obsessed with personal robotics. I'd been obsessed with robotics for forever, but home robots, I was like, there's something here. And to me, the fundamental problem was that people had not built affordable hardware. I had worked with the vision system. I had been building the control system and stuff for a spherical robot. I was like, software can create a robot that is useful, that is beyond a Roomba, that could actually do something right now. Software and compute is up where it needs to be. But there is no body for me to put this hardware into. At the time, there was like the PR2 from Willow Garage and robot arms from like Rethink and UR. All of these cost $60,000 or $250,000. I was like, well, there's the problem. The reason we don't have home robots is because nobody can afford the home robot. Not because the software is expensive, but because the body is expensive, because nobody's getting that. I was like, well, I'm a pretty good mechanical designer. So over that year, I worked through many, many designs for a personal home robot. And I was like, what is the minimum viable product for a home robot? It has to be mobile. It has to be an arm that interacts with a normal human house, normal size house. And it needs to have as few components as possible. Ultimately, so I started working on that. And by the time I graduated, I had a pretty solid design mechanically for that robot. And I was like, this is something that's useful. And if you build a robot body that is affordable enough, then the developer ecosystem can grow up along with it because there's some place for it to go. I was like, robotics is stagnating because there's no hardware platform on which to operate robotic software. Software can run as fast as it can so long as there's some hardware to work on. So I was like, can I build a $2,000 robot that is useful inside the home? So, Slant Concepts, its operating project was to build that. We paid the bills through design consultancy. A little bit background on the design consultancy. I did one internship during my college career. I worked at a company called Andrews Cooper. And I ended up working with a bunch of projects for HP, which I'm pretty sure I still can't talk about. And I worked on things like the Microsoft smartwatch, which I can now talk about because it's such a wild success. But I remember my supervisor having me sign a second NDA when I was brought in on that. But they were a product design firm, and I liked that, and I worked on it. And my experience with that was really useful. With Slant Concepts came on out and did it. By the way, anybody who's a young engineer and is like, we're going to start an idea factory engineering firm, don't do that. It's a really bad idea. It's a terrible business model long term. It's a terrible business model to cash flow stuff. You end up starving because you're fighting for the new project all the time. But I digress. Started Slant Concepts, a stupid engineering firm that you shouldn't do. But it was to cash flow the creation of Jerry. It was the Jerry project. And we got the body built. And the body was very unique because it was wooden. And yes, I know I've mentioned wood a bunch inside of this stuff, but wood is a really good material and underutilized, especially in robotics. And what I liked about it is I thought I had the philosophy that a home robot, which is a large thing, should be invisible until it is called upon. It should be a piece of furniture until you ask it to do something. Then it unfolds and it does whatever it's doing. So that was the theory. He had a door on the front that opened up and his arm raised up, and he would do whatever you needed to do. We got him built. In about 6 months, we built the baseline hardware system and redone the vision system, got him into telepresence mode, got him on remote control, and got a basic demo of clearing a room. I designed the vision system for him again, and we got him to where, like, if you were in a room, he would map the room, he would view the room, do a camera scan of the room, use stereo vision, camera scan of the room. If anything changed in that room, he would put it back the way it was. So, like, if you threw a shirt on the floor, he would grab that shirt and say, like, this is a foreign object that I don't recognize, put it over in a hamper. Something like that. That was the baseline demo. Go grab a thing that doesn't belong. And I thought that would be enough. Here's the problem with home robots. Home robots have to be fully human or as dumb as a Roomba, and there's no in between. There's no market for in between because they're too expensive in between. They're a gadget. They're a tchotchke otherwise. If they cannot do everything a human can do, then they had better be a single task item. There's no in between. This was 2015, 2016. Machine learning was all the rage. The other problem with home robots is that they are an uncontrolled camera inside of your house. And people really had trust problems at that time because you were just coming out of Facebook's evil, Amazon got hacked, blah, 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 all these things. So it was a really bad time to say, hey, let's put a mobile robot into your house that listens to you and sees you all the time. I thought it was better than like home camera systems. I thought like home security from the robot would be kind of a killer app for it because at least you know where the camera is and you can park it in a corner if you don't want it to be around, as opposed to a smart home where you have an Alexa in every room and a camera in every room. That's surveillance. But anyhow, worked on that, tried to kickstart it, got a few people going, didn't get any funding, and I thought that it probably wasn't a very good idea. So I tried to boil it down even further, and I tried to go at it at a different angle. I'm like, okay, home robots is not ready yet. The market isn't ready. The tech could be ready, but it's not right now, and it's not worth all of the R&D to build it. So we sort of changed course, and serendipitously, on a weekend, I designed a small 3D printed robot arm. And this is where the journey begins. Small 3D printed robot arm. It was, I finished it, I brought it in, I showed it to people, and everybody thought it was pretty cool, so we put it on Kickstarter. And it was funded. And thus the journey begins. I hated 3D printing. 3D printing was so stupid. So stupid. This was MakerBots, everything else. I knew them. I'd used the DIY ones. What a piece of garbage all the time, forever. The 2012's ideas of a printer in every home was dumb to me. I was like, they're never going to be a microwave. That's not how hardware works. It won't ever work, ever. There's no technological roadmap to where a robot, 3D printer in every home works. Doesn't work. However, I had now had to build a print farm. We bought a bunch of cheap machines off of Amazon or something like that, and I built all of them. I ended up building like the first 100 machines or so for Slant 3D myself. But these first few machines, these first few kits, we were Bedslinger rep clones, clone kits. And I put them together and they were garbage and they'd rattle apart after like 2 prints, but like they kind of worked. And in running the print farm, I got like the fundamental truth of like, oh, we're just putting in electricity and plastic. Sure, this is garbage hardware, but the hardware is fixable. The fundamental truth of what 3D printing can do is correct. You put in electricity and plastic and you get a final item out, and you have all this inventory control, and we can iterate on the product and all the benefits. I was like, this is pretty cool if somebody makes it work. So I looked around and I was like, well, we're making these 3D printed robots arms. It's pretty good business. Let's have somebody else print them for us. Looked at the guys who were around at the time. Several of them became competitors eventually. None of them were viable. They were too expensive. And by the way, I was not a cheapo. Well, no, I was kind of a penny pincher about that kind of stuff. But I was like, we had a fairly high margin product. We could afford stuff. But we were selling $100 robot arms. And in order to do that at retail, you have to follow the rule of threes. So 30% for the retailer, 30% for manufacturer, 30% for distributor. So that didn't work with 3D printed parts. So we were building our own factory. And in building the factory, I was in a continuous improvement sort of process. And it worked. Like the Little Bots grew into a very successful company in and of itself. But it was STEM robotics. And whenever I am deciding what to work on, I want to know how far it can go. What is the ceiling on this? And Little Bots you can still see. It still has a YouTube channel. I think the website is dead now, and we certainly don't sell this stuff anymore. But Little Bots became... It probably could have been sold for $1 or $2 million by the time we shut it down. We were doing, a lot of 6 figures of revenue from the thing. Doing 3D printed robot arms way back when. And it could have gone more. There was a lot more to go. But I knew that this company would top out at like $30 million as valuation, or like in revenue ever. Because that's all STEM had ever done. I looked at the guys at Sphero. I looked at STEMfinity. There were a lot of STEM companies out there that I could use as reference. And there was no one who was $1 billion company. So I was like, it's as much effort to build $1 billion company as it is to build $1 million company. I want to know that I have room to run. So I wasn't terribly interested in Little Bots, but it did cash flow and pay for the development of the print farm. It was also paying for the development of a lot of robotic software. My belief was that Littlebots would continue to evolve. Right before COVID, Littlebots was working on a project for a daily driver robot. Basically, a robot that was capable of following you around for 10 hours per day, whether you're going through the airport or going home or wherever else it was. A robot that could be mobile, operating in your life and interacting with you for a day. That was the goal. The project was called Mo. I have the prototype sitting on top of my desk. And by the way, fantastic product. And I would so deeply love to go back to it because he was so sick. But he was 2 wheels. He was 2 wheels and a camera. But he was very Wall-E-esque in that he had an eye that opened up. He actually, some of the design, it got inspiration from a Samsung ad long back when where they had robots scurrying around. But Mo was meant to be kind of like a dog replacement. Like, could we make a robotic dog that has wheels and is a box that people would actually love? Like, can we make this thing emote well enough? And we experimented with that with the Littlebot Buddy and that kind of stuff where we were building in these behaviors. And Littlebot Buddy we thought was going to turn into an Amazon Echo accessory at some point. So that was the room for growth of that. But then the print farm started taking off. And the print farm was interesting because I was like, robotics is great, but robotics is stupidly high risk. And there's other people who can work on it and other people who are kind of working on it. No one is doing print farms right. And I need this print farm in order to make these robots. So I'm going to go work on the print farm so that we have the infrastructure to build the robots. So I focused in on print farm. And that's when we spun off Slant 3D. And I decided to go run it full time. At that time, we had 100, 200 machines, something like that were working, about 100 machines working on Littlebots and then about 100 machines doing client projects. I think that's the number that's right, something like that. At this time, we were up to like Slantbox V4? Slantbox V4 about this time or so, yeah. So spun up Slant 3D, moved into a new facility, got rolling. And that's when Slant 3D got started. I did a TED Talk around 3D printing in like 2018. This was when it was still part of Littlebots. But we were building the print farm and just like spinning off the excess service for that. But like we developed auto ejection in like 2017, did all the materials and stuff for that, had developed our own machines way back then and continued to use it all. And then, yeah, COVID happened, so on and so forth. We did face shields and that kind of stuff. Much of this is fairly on record. And my life hasn't changed much in that span of time, short of just working on Slant 3D. But that's kind of the history of like where I came from. Started out as a ranch kid, made good, went to became a robotics engineer, and 3D printing found me more than I found 3D printing, because I was never a fan of it. But now I am, I would say, one of the bigger supporters of it. One of the louder voices in the industry. So it's funny that way. But yes, hopefully that gives some context to it or so. But yeah, I would say many of my philosophies were very formative in my childhood, because ranching is just such a different sort of lifestyle that a lot of that has now moved into like how I operate the company. We're very long-term, we're very frugal, and we take a lot of pain that a lot of people wouldn't otherwise. This is the interesting thing about this. Like a year ago, one of the guys on the team asked me, Gabe, how do you deal with all the negative comments on the YouTube videos or something? Because we honestly don't have that many negative comments, but they come up, and it's YouTube, it's the internet, is what it is. But my response was like, I've been kicked by a horse, guys. Sticks and stones. I know what real pain is, and mean words on the internet ain't it. So that growing up in that way is just stupidly useful, because starting a business is so painful, and people don't say how painful it is. They don't let on how painful it is. But it is longer, it is harder, and it is worse than whatever it is that you imagine. Definitely. And there is always something broken. I was literally just reading a management book from a guy at Google, and he was like, I turned into a manager, and then suddenly I saw all this chaos was all around. And I said to one of my buddies, hey, why did it all get so chaotic all of a sudden? And the guy was like, it's always been this chaotic. We protect everybody else. That's the job of the manager or the leader, to not let the stress go down to everybody else. And I was just like, oh, that's good to know. Everybody else's company is always on fire too. You just don't know how. Freaking Facebook, untouchable, $1 trillion. Apple doesn't want you on their phones anymore. Ooh, that's kind of existential for a big old company. So you're never done and the fight is never over, and it's just really painful to start a company. But I have been kicked by a horse, and this is easier. So that's how I'd sum it up. I thank you to anybody who's like still here. But yeah, we thought it would behoove us to have a little bit of history about me, like on the record out there, so people know where I'm coming from with a lot of this stuff. And yeah, so hopefully that's kind of the history of the work that I did and that kind of stuff, and where I'm coming from now. Right now, my job is mainly as a manager to try to get other people to do really good work. That's my main job anymore, is to build a team that is able to execute on our goals of letting a kid in a dorm room build anything for free and get it sold and not have to build a giant factory. And we've done that. Like, we've hit it. And now it's just a problem of continuing to refine that and take care of everybody and do a good job. And you know what? Growing up on a cattle ranch is pretty helpful. Being an engineer is pretty helpful. And having been involved in the design of over 200 products in my reasonably young career helps a lot with that. So, yeah, hopefully that gives you some insight. Have a great day, everybody.